Hi, I'm Raj Sodhi. In the following video, I will present a data viewer for data collected with the WaferPro and WaferPro Express software. When you run a test routine in the WaferPro Express software, it organizes the data into a deep hierarchy of directories based on lot name, wafer name, temperature, device type, polarity, and reticle location, and then specific measurement parameter groups. If you want to put the data from different die around the wafer side by side, this hierarchy can be a little cumbersome to navigate. What kind of data do we want to plot? We want measurements over bias, like a parameter sweep, and across the wafer, either as this wafer map here, or represented as a histogram. The new data viewer introduced in ICCAP 2018 allows for all three: navigating the directory structure, finding relevant data, and generating plots so you can think about what this data really means. Okay, so let's do a quick demo. From the main ICCAP window, we can launch the data viewer. Here we see the welcome screen for the data viewer. We have scalar quantities and vector quantities. For vector quantities, let's say there's a sweep or perhaps a parameter sweep, we might have plots that look like this. For scalar quantities, we might want to know the statistics, in which case we'd want to get a histogram. And then we might also want to see how the scalar quantity varies across the wafer. All right, let's do our own example. We're going to create a new plot page. So we will navigate to the top level folder where we know that there's data underneath. It has already detected the device type of MOSFET with wafer_1 at temperature of 27 degrees. There's a die list here, so we're going to select all the die. And then it's detected which routines are available, the measurement conditions, and now we can choose which variables we want. I'm going to select all the variables. If I don't check this, it's going to show histograms. If I do check it, it's going to show a wafer map. And so now we have wafer maps for every single quantity we requested. For example, threshold voltage taken at GM max with a back bias of 0, negative 0.5, negative 1 volts. Next, let's say there's an outlier in some of this wafer map data, and you want to be able to visualize it. Okay, so I purposely created a point where one data point was set arbitrarily high. This is 2 milliamps, whereas most of the data hovers around 1 milliamp or 1.1, 1.2 milliamps. How can we visualize the main distribution ignoring the outlier? Well, we click on color scaling, and we see that the max was set to the outlier value, which is 2 milliamps. I'm going to set this to 1.4 milliamps, and you begin to see a more normal distribution. We still have the outlier sitting over here, but we have a more balanced view of the wafer. Let's say we want to save an image of this wafer map. We click on the Save Image button, and it asks us to choose a file name. So this is I with outlier, and indeed we get the PNG file that it just created. So here's I with outlier. There it is. Let's say you've done a lot of analyses of your data across the wafer. You might have spot data around the wafer. You might have sweep data collected across different die. You might have statistical properties of your spot data represented in histograms. You might have S-parameter data taken around different reticles, and you might have measurements across device geometry. Well, let's say you want to create a report that encapsulates all of your analyses. So you would need to create image files that could then be imported into whatever reporting tool that you use. Well, let's do that. We're going to generate lots of image files. We go File, Export Project Images, select Folder. And now it's whirring away, generating lots and lots of image files. Here are a few of these plots. You have now just seen how easy it is to visualize WaferPro and WaferPro Express data with ICCAP. You can get started today. Download our free 30-day ICCAP trial, subscribe to our channel, and contact us with any questions. Thanks.